Alrighty tidy folks, we are back in Le Garage. With some gooses. There. Making their way north, actually. they might be lost. Mr. Laptop, do not fall. Please do not fall. I don't want you to fall. Alright, so we ordered some bulbs. Here they are. We're going to stick them in the cluster. Stick the cluster back in the van. See if they turn on. I'm just going to do the, I'm going to swap the bulbs and then put just the PCB and plug it in and verify whether or not they all turn on correctly. If they do, we'll put the climate control housing back together, stick it all back in the van. It is balmy 48 degrees Fahrenheit, which is what, 8 degrees Celsius? I don't even actually know off the top of my head. So 48 minus 32 would be 10/6, so 16. 16 times 5/9. 7-8 degrees, yeah. Cool. Random guessing off the top of your head works sometimes. So there's a balmy 8 degrees Celsius out here in the garage and outside beyond the garage because there's no insulation in here. When they built the place, they didn't put any insulation over the drywall. They put drywall in, but they didn't put any insulation above it. Smart. Wondering if it would help me kind of get warmed up and moving, cleaning things up first a little bit. I am going to real quick. We're gonna go check the transmission pan, make sure there's no drips underneath it. Be right back for that. Dry as a thing that is not wet. I would say dry as a bone, but your bones ain't dry. They're actually kind of wet. They're covered in gross, squishy red stuff. Gross, wet, squishy red stuff. I guess. Oh, yeah. Let's turn you guys a little bit. Actually, I opened the browser so I could send the link. To people. And it is that which I will do right now. Alright, now, it's been a few days since I streamed. The last one was me trying to stream Ixion, which was quite unsuccessful. Still haven't figured out how to get it working yet. Did record video from the tutorial, and I tried screwing with the tutorial a bit while I did that, but it wasn't really all that interesting. More just, you know, regular old gameplay, nothing to write home about. Let's bring you guys over here so we can hang out and I don't have to scream across the garage. Would you just do the thing? Thank you. Jesus. Oh, let's put you guys right here. Okay. Just take the mic. Kind of like that. I'm going to put this glue away. No, I'm not, because I might actually need it for the rear door. We can put the Shinetsu away, though, because lubing the track does nothing. Come to find out. Window is slow because the regulator is old. I also need to shuffle cars around. Every day I'm shuffling. How that works. Alright, so first things first, boy. Let us grab our little bulbs and see if they fit in the first place. They appear to fit in the first place. The way I'm going to do this so we're going to get us our little fliddly flathead screwdriver here, our screwdriver bit, to try to do these things. And the replacements are just a little bit different. Bulb's a little bit smaller, it doesn't have the little rubberized coating over top of it. Not sure if that's going to matter or not. I don't think it does. I'm going to stick 4 of these guys in here. We're going to get the little screwdriver, give them a twist. These do feel like they fit better in the PCB though. Well, not that one. There we go. These, the OEMs, they didn't really pop into place. They didn't go click. These went click. So, I'm going to take this out there real quick. I don't know that I need to drag you guys out there with me just to plug it in and test it. If it works, we'll go back in. I'll show you that it works. I'll stick you guys up there, top down, and we'll put the cluster back, or we'll put the climate control unit back together, and I'll drag you along for that. First, every day I'm shuffling. Our driveway is wide enough to fit 1.8 vehicles. I say 1.8 because you cannot fit two vehicles side by side and get out of the sides that are facing each other. I've got to move a vehicle so I can get into the van in the first place. Smell that Richie Rich. Yum, yum, yummy. Alright, let's grab, move this tote that's in the way. Then let's grab this guy. Again, I will be right back. I don't need the key. I'm just going to turn the parking lights on to test. Maybe I do need the key. Nothing's working. This is, yeah, just switches. Meter. Oh, the meter. My voltometer. Voltmeter. 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 Alright. What? There's someone inside. You guys let me leave it inside. What'd you do that for? Go check. It is. We're going to try key, and if key doesn't work, we're going to check the voltage and see if the bulbs are getting powered. They're just not making a connection. Okay. Well, they're not getting powered, so we're going to try plugging in the various switches. See if maybe Chrysler didn't run the dash lights to the climate control through some switch or another. Should be a very Chrysler thing to do. Took me a second, but I finally saw what they did. And, like I said, it's a very Chrysler thing to do. So, story time, perhaps. We're going to give you guys the top down real quick. So, we can put, come on. Tape, do the tape thing. It may or may not be doing the tape thing. So, story time. There was once a job. There was a guy that had a car. And this car that this guy had blown an engine. And the guy liked the car. So he wanted, and that goes the other way. So he wanted the engine replaced, right? Obviously, you like your car, your engine blows, you want to replace the engine. So we said, okay, it'll be, wait, does this go? It doesn't go under this, does it? It never came off, no. Definitely goes on. I remember pulling it off top. Oh, I remember pulling it off of there. Just sit like that. Huh. So, we said, okay, it'll cost this much to replace this engine. He says, that's fine. I just want my car back because I like this car. Yes, sir. Absolutely. So this vehicle, the vehicle in question, was a 02, 04 Sebring, Chrysler Sebring. To this day, my standard of measure for something in particular. So we go and we start taking this thing apart and we're like, we look at the, what you call it, we look at the book and we're like, it can't possibly take this long to do this job. Like, there's no way. And we start getting into it, and at every turn there's something. Just something that you have to take something else apart. Granted, you're doing the engine, so you got to pull everything in the engine bay apart anyway. But there were things, I don't even remember what they were today. It's been long enough ago that I don't really remember exactly what the problems were. I remember the last problem that we had. The last problem that we had was we were trying to pull the engine out, and there was one bolt holding it. So you put the cherry picker on the engine, and you start jacking it up to relieve the pressure off the bolts. You pull the bolts out, and you pull the engine up and out. Job's a good one, right? So we did that. And we got all the bolts that we could find out. We're sitting there, feeling around blind, trying to figure out if there's any more bolts. There's no more bolts. So we're like, okay, well, that's got to be it. So we start jacking it up a little bit, and we try to wiggle it, and the engine and trans are wiggling together. And we're like, well, that's not right. still a bolt there. To make a long story short, I spent an entire day trying to find that bolt. My buddy, or boss, or coworker, or I don't even know how you call him, he spent an entire day trying to find the bolt. We gave up on it. The next day, went and did something else. And then either he looked it up or he got tired of it and went back to it and was like, you know what, we gotta do this. It's almost there, it's just one freaking bolt. Come to find out, it was underneath, same thing with this, actually. A bolt that you can't get to because of a damn water pipe. Because they could not simply be bothered to think about where these things were placed. And you have to remove something unrelated. I mean, R&R engine, everything is related. But you have to remove something unrelated to pull the transmission off the engine. You should not have to disassemble the entire cooling system. Sure shooting, there is a water pipe, and that water pipe was the main water pipe hiding that one last bell housing bolt. And unlike this one where you could actually see it, you couldn't see it. It was between the tube and the bell housing, directly in line. So there's no way to get your finger in there. There's stuff in the way. There's a transmission. There's a head. You just can't get in there. So he went over there and he just started taking stuff apart, and he got the thing. He got the final bolt out, and so that ever since that incident, the measure that I use to determine a vehicle's value to me is it as bad as a Chrysler Sebring? If I can readily, clearly say no to that, then we can move on to the next step, whatever that step may be. When I got to my last job, working on radars, we go out there, and the guy, so like, you know, you get out there and your boss, your supervisor, whoever is, he's giving you the introduction, telling you, okay, here's this piece of equipment, here's this piece of equipment, these do this, and this does this, and these do these things right here, and blah, blah, whatever. He's walking you through it. And so he's doing that, and he starts on like, yeah, it's older, the metallurgy's not really all that great, this is always happening, and this does this, and this does this, and he's telling me like about common problems with the machine. And he's like, sometimes this thing's just really a pain in the butt to work on. I'm like, as long as it's not a Chrysler Sebring, I don't care. And of course he gives me that look like, dude, it's a radar. It's far more complicated than a Chrysler Sebring. And I'm like, no, you don't understand. 3 days to remove an engine. Like, it should not have taken 3 days to remove that engine, because that one stupid bolt. That is a complete and utter absurdity. It is silly, it is absurd, it is nonsensical, and it should not have occurred. Period. The heck was that? That was a funny noise. No idea. Not a clue. You know, it would help if I were not apparently a dummy head. And I put all the screws back in the unit, right? But that also gives me an opportunity to show you the stupid par for the course Chrysler thing that I found. Sitting here talking, not paying attention. Which, I mean, it would have gone together and it would have worked. Will you do the thing? Thank you. Okay, these guys all go in here. So no. What? That's the long screw. I was like, wait a minute, this don't make no sense. Uh-oh. Ruh-roh, Reggie. Do they hold this to this? Is that the question? Is that the... Oh, yeah. Okay. Okay. Well, while we've got it apart. So, I'm looking at this and I'm like, okay, well, this connector here that's all small, low power stuff. You know, you have temperature doors, 1 and 2, and you have blended door right there. Well, that's a lot of pins for 2 temperature doors and 1 blender. So it's like, okay, so it's got the power for the bulbs, and it's got, I think this guy has CAN bus to try to tell the computer if there's a problem with the control unit. So there's going to be that in there. That's going to be 2 pins, you know, so a bunch of pins, right? So I plug this guy in, turn on the lights, nothing. Maybe it only gets powered with the key. Okay, so we grab the key, turn on the key, turn on the lights, nothing. I'm sitting here and I'm looking at it, I'm like, okay, well, where else could power possibly come from? And I see these big lugs soldered onto the board. I'm like, there's no way. There's no way you'd be that stupid to design that like that. So I came back, that's when I grabbed this guy, because this is the blower motor, okay? This is the blower motor. Control knob. It's just various rotary switches in there. Big power runs through there. Full power for the blower motor runs through this switch and out, which is kind of silly for this 2006. It should have been relays or PWM. Anyway, runs out of here. What also runs out of there is those, and this one comes out of the what is that guy? The rear fan. Okay, so these are both the fan switches then. So, rear fan, front fan, and you got lugs. So I went and I grabbed this, and I put it on there. Bam-a-lam, lights all come on. Like, who let you people out of the facility where they kept you? Who comes up with this? Answer. People that have no idea what they're doing. Like, why would anybody let you touch any kind of design software if that's how you're going to design things? That is dumb. Completely, absolutely, 100% dumb. There's no, oh, there's a bunch of different ways of doing things. No. In this case, no. You do it correctly or you don't do it at all. No. What? Why are you not? Sneasels. Okay, so all of those go. I thought there was some inside. Yeah, I guess I was right the first time. I'm not as dumb as I thought. I thought it was 3 screws holding it to that bezel, and then some screws in here holding these two together. Apparently not. I was right the first time. It just, this whole unit plops in here. Get some screws in it. Okay. Okay. Okay dokay. That work is for me. I'm also going to take, real quick, this whole unit back out there, which I guess I'll drag the bezel and you guys and the climate control once he's all back together here. Drag all this stuff out there. Before I stick him back on and stick the bezel in, we're going to discount, double check them, make sure all the lights continue to function correctly. Make sure the job will in fact be a good one. I am just going to stick all these knobs back on real quick like. Oops. Oh. Interesting. A little notch here, and I'm not quite sure what it's for. But it's interesting. All the knobs work. Passenger goes on the bottom. Driver goes on the top. Kind of like that. Alright, now we're going to grab all of these little screwy screws, this and this. We'll take them, put them outside real quick. And then grab you guys. Oh, tape. Now I want you to not do the tape thing. Cables, cables. Cables, cables. Cables, cables. Cables, cables. Cables, cables. I need to string this cables out to the road and untangle them. That's what I'll need to do. But not right now. I'm also going to roll this window down just a smooch. so that I may pass you guys through the window. Oh. In through the window. The lady couldn't understand how the robber got into her house. All the doors were locked. It got intruder window. I don't remember how that joke goes at all. Okay. I don't know where to put you guys. How far does this go? I wonder. Can we like... No. The way the window's angled, it's going to crush the cables before it holds down the camera. So, I guess we're just going to stick you guys on the dash right now. Yeah, so, plug in just this one. Actually, I'm going to pick you up here again in a second, because I'm going to show you this. So, we plug in just that, right? Come here, Mr. Cable. One would think you're not just going to sit anywhere helpful, are you? No, it's not going to sit anywhere helpful. Will you wedge? It will wedge. Okay. So you'd think, plugging in that, turn the lights on, you'd get something. When in truth, you get nothing. Sure. But, if we take and we plug in this guy, okay? So we've now plugged in the fan controller. The fan is off. Both fans are off. We're not plugging in the rear fan for right now. Both fans are off, and you're not going to sit nicely anywhere, are you? Both fans are off. Key. Lights! Which the one in the middle sucks. The one for the rear, it's really dim. But the lights work. Using power supplied from the fan header. Wow. Just wow. And I think I just realized what that little blue topper thing is on those bulbs. I think it's a UV blocker to prevent the plastics from decaying as quickly internally. These halogen bulbs, they produce UV light. I mean, they're all lit. Okay. So let's pull. This is just such poor engineering. Such incredibly bad, poor, not good engineering. This whole thing. Anybody that can look at this and think that this was done well, that it was done correctly, that there is anything positive about the design characteristics of half of this machine, they need to go take a look at the rest of the planet. Because while the rest of our species
is progressing, learning, figuring things out. We're stuck here in our secluded little cave, screeching at them because they walk upright. And we don't trust the newcomers. Which, they've existed longer than we have, so, you know, they're not the newcomers, we're the newcomers. But, you know, it's... I don't know if it's American school systems teach it wrong, or... Because there is a thing, there's an effect, an artifact of the way our brains work, and that the language one possesses can and will affect the patterns by which they process information. So people who speak English will see a different first solution. Really? Than someone who speaks German, who will see a different solution than someone who speaks Japanese or Mandarin. Right? And I don't know how much of that is directly related to language, or the effect is noted as language by artifact, because the language you speak is going to be then derived from your culture, the culture that you are raised in, that you take part in, etc., etc. So I don't know how much of language changes the way you think is based on language, and how much of it is based on culture. Because it is, for sure, an effect that your culture will play a large role in how you process information. There we go. Alright, and we put... Cup holders back in. Ba-ba-ba, job's a good'un. Dash lights up. Very, very ugly. Really ugly. Because they're not the same lights. But the same lights were going to be $150. So I think, in this case, the cheap and functional and effective is the better option than the OEM and guaranteed correct. I do believe in this case that is the case. While we're sitting out here for a minute, I'm gonna untangle my cables. Untangle my cables. I don't know why that song's stuck in my head. Woolly bully, woolly bully. Just stuck in my head, man. Don't even know where it came from. Haven't heard that song in 20 years, probably. The things that just pop in there and won't go away. Ta-da!
Pax Pups, who wasn't related.
Shut up. Oh. Shut up. Grab the tools. Take them inside. Gotta leave you guys in here for a moment while I take the tools inside. I'll come back out and grab you. I was going to do some stuff in the V-dub, and I was going to check out these side doors today, but it looks like it's going to keep raining on and off all day, probably, possibly, potentially. So I don't know that I'm going to do that. I am going to get the radius gauges out. Come on, turn the key. I'm gonna get the radius gauges out. I'll bring the Volkswagen up here in the driveway. Because we just got notified that we got to get everything off the road for when it snows and the plows come through. It's not a thing in Logan, but it's a thing in Providence. So, the place where I live specifically says you're not allowed to park on the road. Yeah, well, thanks, guys. That's helpful 4 months out of the year when you own 15 vehicles. And you have a driveway and parking area for 3. And anybody that can claim this is a 2-car garage should be waterboarded. They should be put on the rack and slowly made to be a foot taller over the period of 8 months. I don't know, that might actually be comfortable. Now that I'm thinking about it. It's like, just pull me apart, crack, crack, crack. Oh yeah, oh, just like that. Like, not fast enough that it hurts you, slow enough that it's really annoying. Well, I guess let's pull the V-dub in real quick. Up. Not in, but up. I guess I can let the van down, it's not leaking. And I will have to do the radiator before it can go anywhere. The radiator's just cracked and spewing coolant everywhere. Which, I need to get a hold of the customer so I can talk to her, see what she wants to do. She doesn't want to do the radiator. It's like, the radiator. It's like, yeah, I'll put coolant in it, I'll buy 10 gallons of water and I'll drive it back up there. That is something I will do. He's Volkswagen. He's Volkswagen. So, let me jingly jangly. Let me pull the LVW up to the garagio. And we'll get our radius gauges hose. We'll do some measuring. I gotta go get my notebook. Where's my notebook? I think it's inside.
Oakley dokley. Alright. Now. Oh. Where, oh, where, oh, where did I stick them? Where, oh, where, oh, where did I stick them? Where, oh, where, oh, where did I stick them? Radius gauges in the morning. Ta-da! Radius gauge. Radius gauges. Halfway through a word. So, these are 3D printed. I think I printed them in ABS, actually. It could have been ABS. The backs are smooth. It's got to be PLA. Or PETG. It might be PETG. PETG sticks to glue. Actually, yeah. This was PETG. I had to sand the backs because the glue got hard after it heated up. So, PETG radius gauges. You can see, our teeniest, tiniest little one there is 3 mil. Our biggest one there is 20 mil. I need to find, I don't want to have to make it of my own. I can make it of my own. It's not that hard. You take a rectangle, you draw 2 circles, you put them near each other, and you cut the circles out of the rectangle. Easy peasy, really. But I like these over the big panel radius gauge because it's easier to get these sometimes into places that you can't get the big panel. Of course, it's raining, which is why I'm not going to be doing the door today. But I can come over here, measure. I can't come over here and measure. I can come over here and set this down and go grab my notebook. That's what I can do. So, let me go grab the notebook. Ooh, I just had an idea. Normally, I don't mind the rain too much, but in this case, rain, go away. Come bug me on a day when I don't have to go outside. When there are not things that I need to do in the outside world. So, there's my drawings of the stuff there. So, I'll just pick the camera up and point. It'll be easier instead of trying to look around it and point. So this is the body, and I didn't draw any of it to scale. I just use it to give me a rough shape, an idea, you know, what's what, and then I provide the measurements. You know, I don't have to set them over here to the side like that. I could draw them in there. But when doing things like this guy, where it's small anyway, or doing things like this where you got stuff stacked on top of other stuff, it is, at the end of the day, much easier to just draw a letter or some indicator. You can use whatever you want. You can use shapes or colors, or it doesn't matter. Just the indicator that you know what's going on is all it is. So you have, I guess we can separate this. So this is the body side, this is the steel, and you've got this right here, which is just the shape, the perimeter of the flange, which has some dimension from this wall to this wall A, and some dimension from this wall to this wall B. It is a parallelogram. They are the same measurements at multiple points. It is not this drawing where it's some rhomboid of some kind. And then C is going to be the outer radius of those, not filled in yet. Radius gauge. No, 4! Don't fly away! No! Okay. And then at the lip of this, there's a flange. Right, so the steel comes... You got the panel of the steel, and it comes up, and then you've got the panel of the steel, and it comes up, and it's right-handed. Shut up, leave me alone. I'm not right-handed. So the height of the flange is the same all the way around. Within some variation, there's a 1 millimeter variation, but that could very well be dirt and debris, and because I tried to clean it off, but it's still just a bunch of crap under there, and I'm too lazy to do much more of it. Also, there's a radius here, and the where is the over there. Mitutoyo. The micrometer, the way the end's built that you use to measure this type of surface, I guess, is narrower than where the radius comes down. So it was, best guess, it doesn't matter. We're not using all of that lip for anything. I just need to know that there is a lip there. That's kind of what the seal's going to look like when I get done with it. Cross-sectional. And then this guy is the air box, which I do not have written down. So... and it's got 2 different lands for seals, one of which was used factory. With this kind of step, for whatever reason, they're not the same surface, which is injection molded. You can do kind of whatever you want, but I don't understand why there's 2 different seal surfaces here at 2 different heights. And then, so the outer height is going to be higher, further away from the body when the airbox is bolted to the body than the inner one. So what I'm going to do is I'm just going to make the seal. It's going to have that ridge that is the little separator between there. And the seal's just going to be shaped for sealing between the airbox and a plastic adapter that I'm going to build, which is why I need this measurement, right? So that's 17.5 millimeters, right? 1.75 centimeters. I'm going to make a ring that is 4 millimeters narrower, so it'll be 2 on each side. So it'll be 10.25 centimeters. I'll probably just do 10. We'll do 10.25. 10.25 centimeters in this axis, and 14.5 centimeters in this axis. And I'm going to take that adapter. We're going to print it out of ABS, so it's automotive capable, and we don't have to really worry about it. And that's what's on the printer right now anyway. And I'm going to print it solid, which is going to take a lot more material. And it's going to be a much, much longer print. But it's mostly straight lines, which means I can crank the heat up a little bit and turn the speed up a little bit. There's not a whole lot of small radii or strange features, so I can crank the heat up to melt the plastic a little bit more, and turn the speed up because effectively what I'm doing is turning up the temperature and the static pressure in the nozzle. That will make more plastic come out at a faster rate, assuming the heater block can handle it. I need a volcano. That's what I need. I can do this stuff kind of quickly. But luckily, the only time you should see temperature variations, honestly, while printing, is going to be in the turns, because it's going to go... I think I'm going to have it solid and concentric. So it just prints sort of in a spiral out, up a layer, spiral out, up a layer, spiral out, up a layer, spiral out, something like that. Sounds good to me. Okay, now I'm not taking the book out there because it's raining, but I will take my plastic, non-moisture sensitive radius gauges. Actually, I need to put these up on the wall out here somewhere. I've got a little bracket that you can slide this into with screw holes, so you can just screw it to something and clip it up on the wall there. What I need to do. I also need to reprint 8 and 9 because they're a bit not great. Let's see, 8 and 9. I got some funny artifacts on them from... Not sure why 8. 8 is weird. 8 printed kind of funny. Oh, because it lifted. That's why. Okay. And then 9 is because there was like stringies or something. And instead of sanding it down, I cut them off with a knife. It's fine. We're fine. Everything's fine. Don't need it. It's fine. So, actually what I'll do, we can turn you guys. There you go. Now you can see Le Volkswagen. While I reduce gauge. Okay, first one we're gonna do. Body is the body. Larger than 18, probably larger than 20. Very much larger. Craps back. Okay. How do you measure a radius without a radius gauge? I'm not 100% certain. If these guys are measurable. And I'm sure they're miserable, but you know. So this is probably going to be the same as the body. Yeah, it looks like it. That is larger than 20. Not by much. That's smaller than 18. Yeah. Smaller than 17. Yeah, some of these don't come out very easily. That looks to be a 16 mil radius. No? Sure it's not a 17? It might be a 17. Okay. So, I guess then the question is how do you measure these radii? So, we know that one, 17 mil. What we don't know is the other 3. Can you just add this distance? Is that how that works? Oh, bye. That might be how that works. I don't remember geometry well enough. Off the top of my head, $16.72. Even if you add 8, it would not be
No. So it's not that simple. I didn't think it was. Okay. So katoa. Probably gonna have something to do with that, huh? I need the interwebs. Do. Okay. Okay. No, go away. Jesus. What happened to the days of you had to go opt in to people stealing your data? These arcs appear to be concentric. Yeah, but how do I get the one on the body? Is it concentric to the outer? I mean, it's got to be concentric regardless. Otherwise, it wouldn't be a seal surface, would it? Not what I'm looking for. They're talking about CNC stuff. Don't care about CNC stuff. No math. How are you doing numbers without math? I mean, FreeCAD's probably... tell you what it could do. Measure from the flat. So okay. So I could do that. From there to there, which is, it says 20. Why doesn't 20 fit? Larger than 20. Like 21. There's not going to be an effective means of measuring it using angles, just straight angles. Yeah, that's in something you already have in CAD. Yeah, everything's talking about stuff you already have on the computer. How do you do it in the real world? The internet has become useless. Because search algorithms make assumptions about things you want. They don't simply search for the results that you've requested. That's the problem. So, what I'm going to have to do is use the one known and build out from there in concentricity. Okay. Fine. Lots is a fine. Is there anything else I can do out here today? I don't think there's anything else I can do out here today. I should go in there and start making this in CAD. I need to get a hold of the owner of the van. I've also got these bad boys. I've also got these bad boys. I got for like 40 or 50 bucks. Yeah, like 15 of them, 20 of them, like 40, 50 bucks. They're 12 volt guys. I am just going to run them white. So we apply 12 volts to all three. Ground to the white wire. Don't know why it's white for ground, but that's what we're going to do. And they Yes. Whatever. Whichever. That's fine. There. They come apart kind of like that. Got sticky on the back, which I might end up having to do something different with. But I can build a little flange with a 3D printer. What I'll probably end up doing is just getting some little piece of like aluminum angle. And get some aluminum angle, drill a couple of holes in the frame there, and sticky those guys. I wonder how big the power supply in the 3D printer is. I wonder if I have to use an external power supply for lighting, or if I can use... Those are 50/50s. 50/50s are usually like what, 120 milliamp a piece? Something like that? 80 milliamp a piece? Depends on the 50/50. Depends on the manufacturer. Depends on the luminosity. But if we assume some things like worst case scenario, go look it up and find the highest, I guess highest average, and just use that number. Then find out if the power supply in the printer can handle the extra. I mean, I'm probably only going to have to use one of these guys. So, tell me, it says 1 watt. What? Yeah, that's not right. I was like, that can't be right. And I put it in. I put it in a calculator to make sure that I'm doing the math right. Like, that's 1 watt per segment. I could see, but even then, that's going to be like 24 milliamps a piece. No way. Guess I'll try to look them up. See how much power, see how they rate them. Guess I can do that. Alright, need to take this inside so we can get in FreeCAD. Am I doing FreeCAD today? Am I designing this adapter plate and seal mold today? Because that's what it's going to be. It's going to be a seal mold. And then I cut a couple of little holes in there, get some silicone, mix it up, inject it into the holes. I've got some, just some like generic syringe things that I got to measure oil for forks, actually. I guess, yeah, let's go inside and get in FreeCAD. Then we'll start on this. Let
let me change the scene to. Okay. Why is the cannon available? Okay, go away. There we go. Okay, so I go inside. I need to take the mic and the. Do I take the whole laptop? Is the question. Do I need to take the whole laptop? I'm just going to be taking the stream over from the desktop. I guess it doesn't matter. So what we're going to do is and put it back in a moment message up. Yep. Okay. Yes. Really annoying when it does that. Not even centered. Centered. Thank you. There we go. That's better. Back in a minute. Changing hardware. Which means I'm going to mute you guys so you don't get loud clickety poppies. ho, hee hee. Hardy har. And we're back. Okay. Now, we've got to open FreeCAD. I wish you could edit the scene without switching between them. Is there not... Yeah, there's not a way to just change the scene, like work with the scene, and then not change to it. So, we want this guy. We're just gonna do this. This. Not that it matters, but this way we're capturing FreeCAD. I can do this where I'm just running it all around the screen. Doesn't matter. It's still captured in the thing. So if I accidentally change stuff, it's not like, you know, I look less like an idiot. That's what it is. Alright, so we're gonna want a new thing. So we've got to make... The problem is... I just had a thought. What is that distance between... But I guess I just start with the adapter. Let's start with the adapter real quick. Which should be pretty easy. So, length. .25 centimeters. Width 14.5 centimeters. And height up to the top of the lip. Do we want to do the top of the lip? That's the question. Do we want to do up to the top of the lip, or do we want to have it down a little bit? I think we just do up to the top of the lip. And this is going to be 1.75 centimeters. Okay, now we want him to be 10 mil wide. Let's go 12 mil wide. All right, so we'll take these dimensions and take 12 off of them, make another cube. So this is adapter. And we need somewhere for the air to flow through. So we take 90.5 for this guy. We're also going to want to open up this. 145, so 133. And this can be 50, because we're just going to cut through, we don't care. Now the question is, how do you make these? I mean, I guess the easier way, stand by. I guess the easier way would actually be to try to do this in a sketch. If I can figure out how to do, because you do a sketch and then you just pat it.
So if I can figure out how to do a sketch in FreeCAD, SolidWorks is fine. That's how it's designed to be used, is sketching. But FreeCAD is a bit different. So is the easier way actually, I guess we have to build the flange first, because we don't know that radius. Because that radius is going to be the same radius as the inner. Okay. So if we do this, make him these are gonna have because I only have one known value. And that's the problem. If I had all the known values. You should be able to... Hold on. Not you. Oh, hold on. We shouldn't do it that way. What we should do is parallel those guys. Parallel those guys. And then make this. And then make these angles 90s. This guy. Right? This is why FreeCAD fucking sucks for sketches. Exactly this. Okay, so we also need... Really? I have to build construction lines? No. We're not a construction line. Oh, that's not for that. Hey. I don't remember how to do this stuff for FreeCAD. So... the hell? Okay. I should be able to parallel this to this. Thank you. Okay. Now, length of this is going to be 5 centimeters. It's supposed to be 18.5. Okay. Now, how do I make this origin to center? How do you do that? I don't remember how to do that. No. You sure it's not that? I'm pretty sure it's that. But I could fix the length between these points to here and these points to there. I don't know that that's the right way to do it. I swear, simple way is to do yeah, but you don't want it. You don't want it coincident. Is there a coincident straight? Doesn't look like it added a coincident straight. But for whatever reason, it won't move it down. Why? Okay. So those are both centered. Those should be construction lines. I should be able to drag that, and they just get bigger. Okay. It says to a line, but it won't let me do it to the line. I know there's a way to do this. How the heck do you do this? How do you locate it? Here we go. I have an idea. I don't know that this is the way you do it. Okay. That's what I thought. Um, I don't remember how to do this in FreeCAD. If I had SolidWorks, I'd have been done with this already. Because I need him. Wait, can you do center points? Center point, center points? Why can't I right click on that? So in SolidWorks, you can set a center point on a line and make it coincident. So maybe we get rid of these guys. Because we can set a center point on two of these and set them coincident to these lines. And that would give me the centered. Is this? No. How do you... Oh, jeez. Yeah, how do you split a line? How do you put a center point on a line? Guess I'm gonna have to look it up. Because I don't know that I've ever actually looked it up. I smell heat. FreeCAD, create center point on a line. Oh, you just add a node and then constrain it. Oh, duh. So we add a node to each one of these guys. Oops. Each one of those guys. What? Oh. Why won't it let me? Well, let me do that. Okay. Create a symmetry between 2 points. Line. To there. And then, coincident, this. What? I don't need vertexes. To here. How do you... Okay. Okay. There we go. Jesus. Should not be that hard. Okay. So we can discount double check with our... I mean, all the constraints are there. So there's no way to move this, right? No, there's no way to move it. Okay, so that is fixed. Okay. Now we need some circles. We need some circles, and then I need this to this. Then I need this to this. Problem is I don't know the radius. How do you... There we go. Just right there. Done. It wouldn't be there anyway, would it? Yeah, it would. So how do I do this without knowing the radius? There's got to be a way. On something that you can't put a speed square on. And I guess I could bring it in here and give it a go. I mean, if I know the smallest one and I know the biggest one, I guess let's make the smallest one first. And then everything out from that, the circles will just be concentric, and I put the distances between the walls, right? And everything will be concentric from there. So, we don't want this. Actually, we want C. And I so that gives us that one. We need to delete these two constraints. They're no longer valid. This radius? How do you constrain the radius of a circle? Like that. Yep. Radius 17 millimeters. Okay, so now you can't do the operation simultaneously. Excuse me. Thank you. Well, that's not what I want. Just gotta do them one at a time. Alright, make all those 17 mil. This guy's going to be tangential to that. And that. This guy. There. What's the hotkey for that? So, this, that. This. And this, that. This, and this, that. Okay. And then you take how do you, oh, yeah, you have to attach it. How do I attach it? I mean, I guess I don't have to put circles. I could just fill it this. Because I know that value. Right? No, I need the circles because I need to make it concentric. And this is the way, this is the simplest way to make it concentric. Okay, so how do I make these? I don't remember. Wait, do I have to take these out of... Hold on. I might have to make these not reference objects. How do you... How do you make those coincident? How do you attach them to each other? I don't remember. Again, SolidWorks. I guess we're looking it up again. Away. Oh, away! Christ. Yes, I said FreeCAD, how to do this. Autodesk Fusion 360. Absolutely. Okay, do you have to do it one at a time? No. How do you... I've done it before. I've literally done this in FreeCAD. I just don't remember how the heck to do it. It should be connect edges. Yeah, because that's still a single line. That's still a single line. How do I... What? Hold on. Where are these first two? This guy and this guy. Okay, if we delete those, move this guy. Yeah, it's to a point. It is definitely tangent. That's how you do that. But how do you... Ah! I was like, I remember it being trim. Can you make... Okay, well, that's the inner lip. Okay. Ah, yes. Let's work from this angle, shall we? Okay, so now we just need to do another rectangle. Yeah, so this we can fill, we can pad this, and cut this directly out of the next piece. My question is, how do I do a flange with a lip? I don't know. Let's, am I doing? Okay, so we need another one of these. We're gonna need that angle to be 90. How do you mean invalid? Oops. Okay. Well, fine. Then we'll do B. This is 135.5. Okay. And then this guy is H 175. Okay. And then we want, we're going to move him over here for a minute. We want to put some dots on the lines. And we want these dots to be in the middle. Hello? What the hell are you doing? Ah. Okay, something broke. So we'll go back to where it wasn't broken. What is this measurement? This measurement is H 175. What the hell? Okay, that's fine. Need a dot there. Okay, so maybe it's dot line. No. What the shizzle fizzle? I need this dot to be in the center of that. Excuse me. Really? Fucking. How is it invalid? This is why sketching in FreeCAD is a fucking nightmare. Those are parallel. Those are parallel. They stay that way. You do not move them, you do not change them. Are we clear? Damn it. On the line. On the line. Thank you. Okay. 2 points. Okay, so does that mean it wants me to do that and then that? No. This needs to be in the center. You need to... Swear to God, Freakhead. You are f***ing useless. Yeah, that just removes a bunch of other constraints. Get rid of the dots. I mean, I guess if I start doing the circles in the corners and make them all concentric to each other, that will center it. Right? This button. I was like, what am I doing? Bam, 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 bam. This to that. Did you just change? Okay. Now, concentric? How do you make concentric? Is it that? Are these not all locked? All of this. How do you lock it? There's a way to lock all this stuff in place. It cannot be moved. No. Probably the big lock. Or not. Whatever the hell that means. So that needs to be locked down to the origin. I know Freakhead's got this really bad habit of not actually making things coincident when you apply constraints to them. So, we zoom all the way in to a line, and it should show us that. But it's not zooming in all the way. So, let's zoom back out. This is incredibly annoying. Again, SolidWorks, this would have been easy. I'd have been done with it by now. Right a point. Point goes on there. Okay. We can move. Now, I need this point to be some... Why will you not just work? Give me the thing. This is why dealing with solids in FreeCAD is infinitely easier and faster. Because FreeCAD Sketcher doesn't actually work correctly. And it's infuriating. If I set this point to be symmetric to this line, it should move it straight down to the middle. But what does it do? Not that. If I do that, it's deleting a constraint. I want this point in the fucking middle. That's where I want that point. Why will you not put that point in the middle? That's what this is supposed to be for. Why is this red? Because you're drunk. Oh my god. FreeCAD, you are... Why is that point not on the line? Jesus. It's FreeCAD. It's like beating your head against the wall and thinking that you're going to get through the wall. This. Oh. Dumbass. Okay. You got a thing here, right? We make it... Yeah, coincident to that. Okay. To make it coincident to that. Okay. Give me this one. Okay. We want him coincident to that. Coincident to that. Okay. Now, can I get this metric to that? No, there's no method of doing that. Can I get it symmetric to that? I don't know if that worked. No, that removed my constraints for the freaking size. Why? Why would you? Do not overwrite pre-existing constraints. Oh my God, FreeCAD. The whole point of the constraint system is you do this in order. If it's in the list, in order, you do not delete a prior one when adding a new one. If there is no constraint there, constraining something, you can adjust it. If there is a constraint, you set up a flag and you say, I cannot do this because a pre-existing constraint does not allow this calculation. Okay, this song is pretty stupid. Go away. Why did it work for this one, but it simply will fucking not work at all for this rectangle? Why? 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 I ask you, why? There ain't nobody there, so ain't nobody gonna give me a damn answer. Exactly what I did. Maybe because it doesn't want it to be reference geometry? Place that. There's an animation. I'm watching an animation. Because FreeCAD is very particular about the order in which you click things. Yeah, point, then line, then symmetry. Point, line, symmetry. Thank you. Did I not do... Maybe it was because of reference geometry. Maybe that's all it was. Now, I want this point and this point to be coincident. And I want this point and this point to be coincident. Thank you. How do you... Why the hell can you not measure distance? Okay, well, I probably need to make this a different diameter. Okay. And this, our tangent. Why are you moving the other circle? When I tell you to tangent, you move it inside. Christ. Like, where did my constraints on these lines go? FreeCAD sketching is absolutely infuriating. Because it doesn't listen to what you tell it to do. It will just go through and delete constraints. And that's as far back as I can go. Lovely. I apparently didn't notice when it just fucking deleted the constraints on my original shape. Go away. Really? Go away. What the f is wrong with you? I guess we're just closing the whole damn program. Because you can't delete the sketch and start a new one. New. Sketch. Reference geometry. Okay. We now want 2 points. We want that centered. We want that centered. Okay. We want those points. Oops. Coincident. We want those points coincident. We should be able just to drag those anywhere and everywhere. Okay, now we have 2 lines. What do you mean 2 degrees of freedom? There's no degrees of freedom. Well, there's no constraints on those. There's all kinds of degrees of freedom. Okay. Now, we want a rectangle. Like that. Okay? We want these lines to be get rid of that. I want this line and this line to be parallel all times. I want this line and this line to be parallel at all times. I want this to be centered on that. Don't care if you move it right now, because we have not set those as constraints yet. Okay. Now I want this point and this line to be coincident. I guess you have to do it that way. Okay, and this guy. Coincident. Okay. Now I want this to have a dimension. We're starting from the inside, right? So C. That. I want this to have a constraint of I. Like that. Okay. Now, none of this should change when I do something else. Okay? Should I put points on all 4 walls? What happens if I do that? This. And this. Put him there. This and this. There. This and this. There. This and this. There. Yes. I realize it is redundant. It's screaming about it. Fine. Yes, I know those are free. That's fine. It's not screaming about that. Okay. Now, I want to add a circle in here. Okay? I want this circle to have a radius of 17 millimeters. That is a known value. We have that known value. I then want that to be tangent to that. I want that to be tangent to that. Oh, maybe it got rid of that when I trimmed it. How did I trim it? I don't know what the hell that's doing. Okay, so hold on. What if... Damn it. Keep clicking the wrong thing. What if I do that? Okay. And then I put that on there. And that on there. And then that tangent. Does that work? It doesn't let you... You just told me it had a degree of freedom, and now you're telling me it's over-constrained. So I guess those don't make any sense. How the hell did I get rid of this corner before? Oh. Okay, so yeah, that gets rid of that constraint. Why? Why does that get rid of that constraint? I guess at this point it doesn't matter, right? Damn it! Click on the thing. Thank you. Yeah, and SolidWorks has a concentric constraint where FreeCAD does not. Oh, that is stupid. Construction lines. That's how you add concentricity. Ugh. Yeah, like... Hmm. Yeah, so FreeCAD does not actually have an inbuilt method of doing concentricity. Lovely. This is why I much prefer working in solids and FreeCAD, in sketches and SolidWorks. I need Rhino. That's what I need. Okay, so we're just gonna do the same thing we did before. Then the problem is I don't know that these are staying. I guess it's point to point distance at this point. Okay, so yes. And then yes. Okay, so that should theoretically, we all know how that works. That should maintain those dimensions. Right? Right? One would think. Okay, so this guy 17, this guy 17, this guy 17, this and this. FreeCAD is a nightmare. So we can't get rid of those corners until all of the circles are placed, apparently. Right? Right? That's what you're telling me. I keep clicking on that button like it gets rid of the tool when you use it, forgetting that it doesn't. I want to say previous version did that. The problem is, as soon as I clip those, now the whole thing's free and it can move around for whatever reason. How do you tell it that all of these constraints are fixed and they're not allowed to move? I mean, that's the purpose of a constraint. Literally, the whole reason a constraint exists is you're not allowed to move this. It only works for horizontal and vertical distance. the lock. What? What it should do is it should lock the segment to the coordinates. Like if you select this and you select lock, all of these coordinates should be locked. Every single line, you should not be allowed to do anything with it. Yeah, see, nothing moves when I try to click and drag. Give me the damn line. Which means, aside from these lengths on these construction lines, which I guess I could fix them. Yeah, just give me a meter. For the construction lines. There. Nothing can move. Right? Now, if I delete, if I trim this, it's no longer enclosed, and it gets rid of constraints. You should not delete constraints. I need the circles so that I can create concentricity between the next elements. So do I not trim those? Do I just leave this like this? Do that. These are always going to be parallel. Ugh. I don't want your stupid those. I want them parallel. Because for whatever reason, you set them as lines, it'll just move those freaking angles. But if you set these two as parallel, it'll never move. It'll always be 90. Okay. Just like that. And now it's effectively a bounding box. Like this. Except it has no origin. So we set those, oops, as coincident. Set those as coincident. And we set this as, this is the bigger ones. This is B. Okay. And we set this one. This is H. Okay. Give me the... Go away. trying to put these measurements so they don't really interfere with each other. Oh, she's babas. Okay. Now, can I take a circle? Make it concentric. The hell was that? But if it's concentric to that, it should... Unless these are not parallel or symmetric. Go away. Oh my god. I just want to know how fucking long it is. Since measure doesn't fucking work at all. Okay, so move the circle. Okay? This is fully constrained. If I take this, make it coincident with that. That's not how you do that, you piece of garbage. You are constrained. You should be locked in place and not move anything. It's not just me, right? It can't just be me. This is what I'm talking about. Prior constraints should not be able to be modified by a new constraint when placed. If you add a new constraint and another constraint must be changed to apply the new constraint, then you don't do it. Fucking garbage. Damn it. Okay, that's there. Now, when I do this, you should move this center point to here. Right? Maybe that way. Those don't even sit on the same line. What? Oh my god, freak. What have you done? Well, that's why it's moving stuff around. Why? Those radii should be concentric. How do you... What? So in SolidWorks, it's effectively make these lines parallel as your concentricity. So why? This is what I don't get. There's a gap there. How is that possible? It doesn't matter how you work it. If you put a radius between two walls, and you make that rectangle bigger, those radii should have the same center point. Right? But they don't. The hell? What are you doing? What the fuck are you doing? Smaller. Jesus. Yeah, that should line up with this line. Huh. Interesting. Nope, nobody in there. Why? Did it not send it? Hmm. Yeah, for whatever reason, my bug report for Ixion is not actually posted. I don't know why. Why there's no answers. Oh. Hmm. Huh. I'm having an absurd discussion in Discord. There's one guy claiming that water is not itself inherently wet, but the things that water touches are wet. Everybody else is just like, but if water touches water, does that make the water wet? Yeah, but if water contacting another object makes that object wet, then one single molecule of water is all it takes to define the word wet. Therefore, two water molecules in contact with each other are both wet. Okay. if it's the interaction of water with other molecules that defines wet, I think he's getting lost in the semantics is what it is. So the claim is that it takes more than one molecule in contact with some other substance to define wet. That's the question.
I'm not finding the answers that I want. So I might have to just not do this until I can come up with a solution. Just trying to get my roommate to come in here and help me out, but he ain't listening. Did the F series have? I thought the F engine, the F series, was a different valve cover. Because those have the 5-bolt valve covers. Oh, I guess that one is kind of square, isn't it? Oh, okay, okay.
Sorry, I was like, what is he trying to do?
Uh, well, since I can't seem to get my roommate to come out here, I'm going to give him a call. Well, that's what we're going to do.
Your call has been forwarded to an automated
Really?
voice messaging system.
Jerk. He likes to do this where he'll get into some game and then he just like ignores the whole world. It's like, come on, man. Oh. I was gonna try to call the owner of the van real quick. Because I don't really want to continue on it. without verifying with the customer. I don't know, might end up calling the stream early today. Well, I guess it's not really early, is it?
Hi, this is Marie.
Well, three days it's been. I need to get that thing done and out of here. But I can't get a hold of the customer. I don't even know if you guys can hear that. Hold on. Hold on. Hold on. Hold on. Hold on. Okay. Nothing. Like nothing at all. What? OBS. Go to there. Okay. Now if I click the button. Okay. For whatever reason, it was on the wrong audio output. Oh, maybe it reset because I updated it. That's probably what it was. Okay. Well, it would be really nice if I could get my roommate to come in here and help me out with frickin' the CAD, because CAD's supposed to be his thing. He's CAD guy. I don't know why this. I don't know why this. Because these should be... Okay, what happens if I... Okay, so there needs to be a method. Why can I not use the measurement? And yes, thank you, YouTube. Just constantly. Why can I not watch my own stream? Why? That makes no sense whatsoever. I can go and watch other streams while I'm streaming. No problem. But trying to watch my own stream, it just locks up. Like every 2 minutes, it just locks up and it won't do anything. Yeah, but you can't just have it show you a live value. Yeah, well, I'd really rather not my car just sit in Idaho for the next month. Because I ain't driving it in the snow. The Civic does not drive in snow. It can't drive in snow anyway. The freaking tires are like skis. Yeah, you have to have an object. How do you do it in Sketch? Sketch. I type the word sketch in the search bar. Oh, Jesus. Search engines are useless. Quit assuming you know what I want to look for and just look for the thing that I typed. Search engines are useless today. They're completely useless. Existing measurement tools are inconsistent. Yes. Yeah, the only way to do it is to pretend to apply a constraint and measure the distance. So, like, if I wanted to do it here to here, and then cancel it. Yeah, they're symmetrical. So why? Oh, wait a minute. I guess they wouldn't be concentric if this distance is not the same as this distance, obviously. So then how do I deal with that? Do I just radius the corner and put the center point of the circles near enough? Oh, wait. Like, how do I try to line them up as close as I can get them? Is that how I do it? Which means this circle would go away. Let's draw another circle. This to here tangent. This to here tangent. Draw that like that. Whatever the nearest point is. What is the radius of that? 31. What is the radius of that? Closer to 32. I mean, if that's how I gotta do it, I guess. Really rather not do it that way. Tangent, 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 tangent. I guess we'll just do these 32. That's fully constrained. You know, I could. Give me this. Well, I want the line. Give me this point. Give me this point. What's that angle? Not 45. Yeah. Okay. I don't know that I'm going to be able to do this the way that I want to. You guys are in the way a little bit, 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 in the way. You can go there. You can go there. You can go there. And you can go there. Something like that. Oh. Probably just drag them way the heck out, but it's fine. Would this be easier to do in, maybe not easier, but would it be a better idea to do in solids? Because I'm thinking about it now. And my question is, how do I do the Z offset? Because this will give me one surface, but then the other one is offset by some distance in another dimension, in the third dimension. So how exactly do I do that? I think the easier way would be to do it out of solids. I think we start with solids. Okay, so if we're doing it that way, then we've got to, I say, work from the outside in. So A and G. A is 156.5 and 198.5. And it's gonna need to be, how deep is that ridge? Where did I put it? Where did I put it? Okay, so pretty sure these are outside measurements. Okay, that's fine. 10 millimeters, okay. Okay, so I guess we're gonna have to do experimentation. I guess we said it that way. Oh. Okay. Now the inner one is shallower. by 3.5 mil. So what we do is we make another cube. Okay, we're going to call this outer seal race. We're going to call this inner seal race. And that guy measures 132.5. $175. We then need to kind of move him out of the way so we can grab him, we want that, right? And then he is the outer's deeper, the inner's shallower. So this is going to want to come up. Right? So we're going to come up out of this face. Three and a half millimeters. Like that. Okay. Now, I'm going to need another cube that is this minus, how thick did I say the material was? 1.1 millimeter. Okay, so this we're going to copy and paste. And this is minus, that's going to be 1.4. This is going to be for 3.9. Right? Now, this guy, we're going to want to move over here. And bam to bam, we're going to want to do that. Right? We also... What happens if we delete this? Should be left with a little ridge. Okay. And actually, I shouldn't do that. I should do that, fill it all the stuff, and then make the other copy and subtract. You can't do that. Blingle. How do I do that? How do I do it after the fillets? I wonder if there's a scale? I don't think a scale would work. Scale wouldn't work. I also need okay, so this is the outer, which means I need the inner. Because I measured these measuring the outer dimensions. I measured the inner dimensions. Okay, hold on. If I do that, we cut that out. Can I then turn that off? Can I then fillet these edges? Will it let me do that? This is I don't think it will, because it's going to try to calculate through this thickness. So what if I do this? If I get rid of that one. Because this inner is 17 mil radius. Yes, it will let me do that. Okay. Okay. Come here. Come here. Meep. That one. That one. That one. That one. And that one. That one. Okay. Got it. I think I have to do these one at a time. Inners. Well, I guess not one at a time. I have to do them edge type at a time. Because if I fillet these... $17 mil. We should get that. And then, if I fillet it again on the outer edges. Ooh, but that wouldn't be 17 millimeters, would it? Because you've moved out some thickness. Give it a go. Yeah, see? That's a different... So I measured the inside at 17 mil. Okay, so the outside B. It gets thicker in the middle, which means it needs to be less. What? Oops. Wrong button. So it'd probably be 5.5, wouldn't it? Half of 1.1 is 5.5. Okay. Problem is, that looks really thin. Okay, so this piece is that. Oh, which I guess I just do a large... Okay, so no, this is going to be... seal flange base. And we're just going to make him like... Because this is going to be like the airbox. This is the bottom of the airbox. We're then going to build the shapes on top of it to make the lands and the walls. Okay, so this guy needs to be bigger than the largest seal surface. So let's call it 180 and 220. Right? And then we're going to have to recenter this guy, which I'm not quite sure how to do. Oh. I am quite sure how to do. I'm just silly. Okay, we all... So this is going to have to move... Oh. Wait, what? Yeah. The... Cancel. Go away. Transform. Right now we're just gonna stick them like there-ish. We can then move stuff around to get the right depths and angles and what have you. See, I keep telling people I'm not good at cat. I don't know why they don't listen to me. Okay, so... Excuse me. Did you go away? Alright, so... the next thing I need to do, I moved the book away for whatever freaking reason. Because I'm a geniomat. Okay, so that is the inner ring. Right? Let's double check. Okay, so this is C. No. Okay, so this is the middle ring. So I need to make the inner ring. Okay, so this is... middle seal divider. Okay. So this is the divider between the lowland and the highland. Yes. And of course, YouTube cannot be bothered to actually show me my own stream. Live. It just locks up every time. Don't know why. Stupid annoying. Irritates crap out of me. Okay, so... and then what I'll do... I can't do that. Can't do that. I can't do that. I'm going to have to apply... So I'm going to have to make a cube with the outer dimensions of the outer ring, the inner dimensions of the inner ring, and the fillets in between. You can probably do that. We can do that. Okay, so we need a new cube. This cube, we're going to move like over here somewhere. Bam. Okay. This cube, we're going to do the inner wall. Alright, so the inner wall is going to be C 104.5. I 144. Okay. And it's going to get centered to... Oh, bam, that guy. Okay. Oh, I then need to measure... So those heights are the same. Okay, so they all... How do I do that? The way I do that is I zoom in, I grab this and this and do that. Right? No. This. No. What? This. This. That. No. Plane. Align planes. Oh, because it's trying to do it to the line. Gotcha. That. Flashing warning, apparently. Sorry. You should align Z. You're not aligning Z. I want you to align Z. I guess I could make the walls and then just attach. I think that's what we'll do. So we'll just do it this way. So what I'll do is I'll make the walls, and then I'll align a plate to both edges. So this plate, and then I'll just copy it over here, and then I'll make a ring, 2 rings that are offset from each other by 3.5 mil, and align them to one of the plates, and then union that to the center hole, and that way whenever we cut it away, it'll cut away the 2 different lands. Okay, so that's that. We need. So we need this guy. Copied, pasted. And this is minus 1.1. So 3.4. Minus 1.1, 2.9. Okay. Then remembering that I'm going to have to move this well out of the way so I can grab that surface. And actually set it to align the correct things. Okay, then we take him, we cut him out of him. That's 2 things. I then need to fill it. Oh. Crap spackle. Okay, so we're gonna have to do this by eye. Actually, we're gonna have to eyeball this. Because I don't have a way to measure it. Lovely, and I don't know the math. So, we're gonna have to fillet this. The inner fillet of... So, I'm gonna hide those. The inner fillet. Pixel perfect. There. And there. And no. There. And there. That's the 17 mil guy. Okay. Then we need to fillet these again. That corner, that corner, that corner, and that corner. 17.55, right? That appears straight to me. Can I measure that? This guy? No. Wait. That's why it looks thin. Because I'm stupid! I'm stupid. 2.2. So we need to minus another 1.1 from all of these. 2.3. And then 1.18. Okay. Now, that and that. This transform here. Okay. Don't show that. This to this. Align those. Well, we're going to have to delete the fillets. Delete that. Okay. This. Hold on. Hello? Did I break something? I need you to... There you go. There we go. Cut that guy out. And... Okay. Now we do this. Zoom, zoom, zoom. Bam, 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 bam. Gimme. Zoom. Now that's 17. Okay. And then we have to fill it again on the outer edges. And that's going to be 18.2. No, 18.1. Right? Yes. Because the material thickness is 1.1, so you have to add 1.1 to every edge. Okay. Okay, so this is inner seal divider wall. We now have to turn you off. Turn you off. Have to delete that, delete that, delete that. Okay, let's just delete this. Copy. Paste. They're going to be in the same spot. Take and move him out for a moment. And then this needs to be 2.2 less. So, 0.3. And this is going to be 2.8. Okay. Now we do that. That. We measure this. Should be 1.1. Measure this. Should be 1.1. Okay. Now we've done this correctly. Now, I don't know what this radius should be. Although, we just add the distance between the two, right? So turn this on. Turn this on. Turn that off. Turn that on. So we need to align those. Really? You're not going to align it for me? Go away. Okay, well. I guess we're deleting that. Add to that. Go there. Like, this is just workflow stuff, right? You gotta make sure you do the stuff in the correct order. This is gonna be... Can I just do the math here? This whole time. I can do the math there. Okay. Take him out there. This guy to this guy. Align. This guy to this guy. Cut. Okay. That should be centered. Looks centered. Okay, now, the amount we need to fillet this is going to be, so we need to measure this edge to this edge. 12.9. Need to measure this edge to this edge. 14.4. I'm going to take an average of those two. And we're going to apply that as the... yes. Friction. Okay, so... was that 14.4? 4 plus, thank you. 9, 2, 13.65. So, the outer fillet plus 13.65. The outer fillet is the inner fillet plus 1.1. So that's plus 18.1. 31.75. Let's apply that and find out. Shall we? Zoom in. Give me this guy. I only have one visible. Pixel perfect. Zoom in. This guy. This guy. And this guy. Okay, what did I say? 31.75. I was about to put in 6.5. So 31.75. How does that look? Come here. Actually, factually, you know what? I think so. All right, so 31.75, that's 32.85 for the outer. Oops. $32.85. Bam. 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 Yeah, the outer edges are easier to select for some reason. So, 32.85. You know what? You know what? That's looking like a thing. That is starting to look a lot like a thing. The question is going to be, am I getting these measurements in the right spot? Tell you what I'm going to do. I'm going to go grab the tape measure, the mic, and the cabin air filter piece. Real quick. Oh. Okay. We're gonna discount double check. Make sure verify. These measurements were the inside measurements. Which means I've just done all of this wrong. Okay. Because I just built that as though I were doing outside measurements first, then material thickness. Okay. So that's inner. That is 10.45 inner. Yeah. Gotta delete it all. Because FreeCAD, you can't just change a value. Because what I have to do, let's see if it'll let me do it. Because this needs to be, the smaller one needs to be the measured value. The larger one is then the value plus the material thickness. So, this is going to be the bigger guy. That's going to be B. 132.5, which is going to break things for a minute. And then H. 175. And this needs to be that plus 2.2. And this plus 2.2. Okay. Which moves it. That's fine, I think. Because when I do the same thing to the other one, it's going to do the same thing. Right? So. This one should be this is the plus 2.2, right? This is I 146.2. Okay. And this, the inner, 404.5. And 144. Okay, so now they are concentric to each other. They're not concentric to this plate, though, I don't think. So, we can do this manually. Where we measure that edge to that edge, that edge to that edge. Okay, we are 23.75, 21.55. So that is a difference of 2.2. So I need to move it 1.1 that way. And probably 1.1 that way. Right? I don't know that it matters at the end of the day. As long as these are concentric. Yeah, but the way I'm centering it is using this plate. So yes, it does matter. Otherwise, I have to move everything manually. So, 22.5. Yeah, 2.2. Okay. So, we need to move it this way and this way 1.1. So, this guy 1.1, he moves that way and that way. And now I wish you could put these on here and they'd update live. Everything is even. Sweet. Okay. That was actually a lot easier and less stressful than I thought it was going to be. Okay. So, I did measure from the inside lip, so I need to add the 1.1 to the outside. Alright, so now the outside ring. We're going to turn off. This guy's going to be... Okay. This is going to be... middle seal divider wall, I guess. Which is this guy right here. Right? So we built first this lip right here. Then second, this lip right here. Next we're going to build this lip right here. The outer one, which is... I guess that's just on there. There's this weird groove right here in the radii and this outer edge. But this edge here and there are the same edge. I'm guessing that's for the flange, just to provide a little bit more material. I don't think that it matters. So we're just going to have... You know what I could do? Because I was thinking of doing it the same way Volkswagen did. Partially the same way Volkswagen did. But instead of doing that, so the original seal design in my head was that stupid shape. Okay, and that's a stupid shape. That is idiotic. It's dumb. It's hard to manufacture and it's dumb. Now what I'm thinking would you give me the damn pen? Jeez. It'll end up being like this by the time you get done with it, but just do that. Make the little adapter. Oh. Well. I'm thinking make the adapter plate flush with the top of the flange, which is what I plan to do anyway. And then take some light adhesive. Not silicone, but like just sticky tacky. 3M, just spray it, but use a spray adhesive. Or I could put a groove. Yeah, but centering that. So I could put a groove. Instead of doing that, I could perhaps do that. So that would be your seal cross section. So what you would end up having is flange. The seal comes down on top of the flange. Then you have another ridge on that adapter plate that I'm going to silicone down inside on top of the HVAC box. He just has a ridge. Because what I'm thinking is when you bolt this down, just these two surfaces press against the seal. We don't care if they touch these surfaces or not. We just want this surface all the way around. To press against the seal to provide the seal. Because I was thinking glue it to the airbox. And then you put the airbox down against this seal as a flat surface. And you put it down. And it seals against the body and the airbox. But now I'm thinking from the other side. put the seal on the body and then just set the airbox on top of the seal. The problem with that is you have to... Because this is turning out to not be as hard as I thought it was going to be, designing that shape. I'm already halfway there. All I have to do is design the larger ring. It would also appear as though the inner ring is about 1.5 millimeters more. Yeah, but that doesn't matter at all. It's not going to matter one little bit. I then need to make... Ooh. Oh. Huh? Yeah. Yeah, this is a bit, this is a bit of a thinker. Eyebrow. This one. It goes up. The eyebrow goes up. Tell you what I'll do. I'll make the next wall. We'll save it. I'll start on... Oh, the reason I can't do the... because I need the radius. Okay. So I'll do the next wall. And these... I'll use this as a guideline for building the adapter plate. Once I get the adapter plate built and installed... I don't think I'm going to do it solid. I think I'll do like 60% infill. Maybe 45. 45% infill should be fine. We'll do it cubic so it's nice and strong. Or octal, maybe. Okay, so I need one more. I need the outer wall. This cube... Come over here somewhere. Okay, cube... Dimension A 156.5. Dimension 2 is 198.5. Okay. Then I need Copy paste. I need this to be plus 2.2 and plus 2.2. Okay. I then move that guy there, this to this, center. No, we can't do that. We got to do it the other way first. This to this, center. Yeah. Then move him up and out. Okay. And turn you off, turn you off. This to this, centered. Right? Yeah. This to this, mine. Minus. Did it the wrong way. Oops. Okay. Then we turn that off for a minute. We want to fill it this guy. We don't know how much, so we're not going to fill it that guy. So we need to measure. We're going to do it the easy way. So we need to measure the inner to the inner. Oops. Measure. Inner to the inner. That is 27.25. Okay, so it's going to be, 54.25. Right? Turn him off. Get rid of you, which was up there already. I could have just clicked the button instead of opening the thing. That guy right there. Can I move him? I'll move him. Okay. So this guy, fill it. That. 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 And that. Bam. Okay, we're going to do the math in here. 17 plus 27.25 is that. Okay. 44.2. How did I mess that up? Okay. I was like, wait a minute, 5. That's not right. It's 4. But I said it out loud anyway, so it's there and it exists. I said the wrong thing. Okay, so 44.25 plus 1.1 is 45.35. Right? So this guy, that guy, that guy, 45.35, right? Bam. Give me that back. That looks like the same thing all the way around to me. So turn him back on. I mean, what do you think? Same thing? There we go. A little bit better lighting. Same thing? I think it's the same thing. I think we're doing okay. I mean, I could print this as like 2 millimeters tall. I could just put it in Prusa, shrink it down, like save this as a thing, shrink it down in the Z to like 4 millimeters tall, and then try it out. I then need... There is... Okay. So we're going to have to cut the center out. Oops. Right? So we need to cut the center out. The center... But this is going to be... Outer seal divider wall. That's narrower, right? Yeah, that's narrower. More narrow. Okay. And then for this, I wanted 12 mil for the adapter, right? Let's do 10 mil. Do 10 mil thick. This 10 mil is... That should be more than enough, I would think. It's 10 mils like that. I'm funny. Y'all don't know nothing about my funny. I'm funny. Okay, so what I need to do now is I need... I think I want 2 mil on each side. So... Okay, so I need to build another flange. For the body. Okay, so this flange is, I measured it outside to outside. So I needed to subtract a millimeter. Because that was just the easier way to do it. So this guy is... that. And... that. And I have a feeling that this is going to sit inside of probably these rings. Right? Okay, so that's what I measured. That's the outside. So I need to do this. -2. Do this. -2. Then we need to move him over. We can grab him. We're going to center this on there. Then we're going to turn that off, turn that off, turn that off, turn that off. I'm going to center that on there. We're going to do that. That gives us a 1 mil. Okay. Now we turn all this stuff back on. And bring it up out of here. Kind of like that. Yeah, so it's going to sit between those two. So, we can take it from, do the same thing, inner, to inner, inner, to inner, Okay, and that is it's an average of 0.75, so 18.75. Okay, so 17 plus 18.75. That's how we're going to do this. And then, because that is 35.75 plus 1 mil, 36.75. So fill it again. Hello? Guess I didn't have them selected. Fill it again. 36.75. And now, bam. Turn, 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 turn. And this is... okay. Body flange. All right. And then when we look at it, he's going to sit higher than the rest. And I don't know what the depth is between the top of that flange and where it sits inside here. I don't even know how I would measure that. Yeah, I do. But it's in storage. Farkety fark fark fark. Because I could use clay. I have modeling clay. Take some clay. You put cornstarch or flour or whatever all over both the sides of the thing you want to try to measure. Put a bunch of it in here on the airbox. Put it in, mount it down, hold it for a second on the body flange after you cover it in some powder. Pull it off, separate it, measure it. That's how you do that. It's the same method you use to make sure your valves are not going to hit your pistons when you're building a interference engine. Because I mean, for what I need to do right this second, I don't need it to be... Oh. Looking at this, assuming these are concentric, it's a big assumption to make. I know. But if we assume for a moment that these are concentric... Damn it, I keep doing that. What we could do is that only sits in the outer seal. And my problem is, so when I pulled it apart, They had gone to Lowe's and gotten some foam and taped it down. That's how they sealed it. Over time, if it's not a single piece, over time as it shrinks, where you have that meeting point is going to separate, and that's no longer going to be a seal. Right? So, the seal that was a single piece seal was this seal, the seal to this flange. So what I could do is I could just make a mold for that. And just have the one seal. But I'd really rather have... I guess I could do a dual seal like they had in the first place. I'll keep doing that. So I could do the molded seal. I could make the molded seal for this. I guess I could just do it. Sort of as an O-ring, I guess. Just make a mold that's a square cross section, and we'll just glue it to the air box, and then when you bolt it down, it'll sit along the ridge here on that edge of the body flange, and that would seal, so long as it's a single piece. I don't understand why they needed two seals in the first place, though. Because there were two different seals. One of them was what appeared to just be an airbox seal. It's the same kind of open cell foam that they use on HVAC systems in cars everywhere. It's on the doors and on the elements between boxes. It's just a piece of foam. The stuff on the inside lip here was foam with a plastic outer backing, or a vinyl outer backing, on two sides. So two sides were foam, and two sides were plastic or vinyl, whatever material it was. It felt like vinyl. It was kind of stretchy and soft. So, and I've got some stuff like that I got specifically to reseal this. I could just put that in there and then make a mold for the seal for just the box to the body, because you can't get it anymore. But I'd really like to have a more effective seal than what was in there originally, which to me... Hold on. Hold on. Hold on. I'm gonna go stick my finger in there real quick. I'll be back in a moment with my non-centered. Why are you not centered? Centered. Centered. There we go. Okay. I'm going to be back in a second. I'm going to go check and see how much space. I'm just going to eyeball it. I'm going to stick my hand in there. See if we can't figure out how much space there is in this thing. Because I need to know if I can make a single seal that goes across that whole surface. Give me just a second. Turns out, I'm just dumb. As it turns out, I am just kind of dumb. Okay. So, when the airbox is mounted to the body flange comes up and just about meets the plastic in the ridge. Okay? It is concentric. It feels like it's the same all the way around. The bits that I could stick my finger onto. So, what I want to do then is I want to make a little plastic adapter to bring the HVAC box lip up to that flange height. No, you can't do that. What if Okay. So the body flange sits inside this groove.
Yeah. Sorry, I was like, what is he trying to do?
There was then foam. Sorry. There was then foam, that vinyl backed foam. On the HVAC box, some distance recessed into the hole on the inner diameter of the body flange. That foam pressed against this race here. Okay? So the inner race. The outer race was supposed to have been a solid EPDM seal glued to here that then got squished by the body flange lip. But that's not actually what happened. Now, what actually happened is the seal did not adhere to the plastic when they assembled it, and it fell down, or at some point it fell down. There was not enough pressure once the thing was installed to hold the seal in place. Okay? And that's our issue, is that the sealing solution is insufficient. We want this to go together and never come back apart again for seal issues. That's the ideal. So I've got 14 different ideas in my head, trying to figure out which one would be the best. So, the body flange goes inside this outer ring. Right? We're not going to cut the flange of the body. That would be silly. But maybe not. I was gonna say maybe we could modify the airbox, but there's where it drops down. There's a lip right here, which you guys can't really even see. There's a lip right there, where this seal surface is different from this seal surface. So I think I still want to make the adapter plate, but it can't be as tall as I wanted it to be. I wanted to bring it flush with the flange. What I need to do is bring it flush with the body. So you have body, and then it wraps up to flange, right? So I need to bring it flush with this plane of the body. And then we can put a seal yeah, we can do what I'm doing already. Where I make this surface in CAD with these height differences and these flanges into a mold. We then do silicone injection mold here at home. It's not really all that hard. Might take 1 or 2 iterations to get just right, but shouldn't be all that hard. Yeah, and with the mold, so one half of the mold is going to be the body side with the adapter. The other half of the mold is going to be this side. We clamp them together, inject the silicone into the mold to make a gasket that will sit on all of these lips correctly. We will need to remove a millimeter from all of it, so when you bolt it down, it'll be interference fit. It'll apply pressure to the ridges, which will keep things in and or out of where they do or do not need to be. Okay. I was doing it right the first time. Okay. Also, what I found is when bolted down, this surface sits directly against the body. I know how tall the flange is, so I know how deep recessed into the airbox it is. Okay. Okay. So, I now need another cube. Move him over there. And he will be the same size as this guy, which is 180, 220. We are going to now start aligning things. So align that. He's going to need to come out like all this way for right now. This flange is going to need to come out to where they meet. And then I need to make the flange 5 millimeters from here to here. So it is currently 9.9. So let's move him. .9 in that way. Okay. We're now going to measure guy to this guy. That is 5 millimeters. Okay. So that is the body and the flange. Okay, and because they are aligned, I'm going to, for the mold, I'm going to have to make alignment pins. Right. So we're not quite there yet, but those guys are aligned. Okay, so this is the body, and so we need to cut the hole out of the inside of this flange completely, and then we need to cut a hole inside of this flange completely. That's our next step. Okay, so this is this and this are getting joined. This will be body side with flange. Okay. And I guess we can just actually, Ashley, did you call me? So we can get rid of him for now. What I want to do is so these two sit at the same level. This one is up about 1.5 millimeters. No. So 1.5. About like that. Yep. He's up just 1.5 millimeters. Okay. And then the lowest point is going to be .5. So it's 4.5 to there. And then from here is 7. 3. That's 10 mil from here to here. Oh, I don't even have my background music playing. Turned it off earlier. Okay. So, now, what I need to do is yeah, so I need to make more tedious. So what I'm gonna have to do is make the lands that go in between here, and they're gonna have to be separate units unless. So I can move this up. I can take this guy, call him 15, It moved the direction I wanted it to move anyway. Thank you. Okay, so from the lip of the inner, which is that guy, to the land is 4.5. So all I need to do right now is measure here to here. That's 6.5. Cool. So I just need to move him 2 millimeters up. Okay. So now that is the inner flange and its piece right here. The simpler way is going to be just to cut this out. Maybe. That might be the way. I mean, it's looking about like the airbox right now. So like that. Oh, I'll tell you what I do. First, let's get a cube. And then, I don't remember these dimensions from the inside, right? I measure from the inside. So that is 1045. And 14.4. We move you over here. Okay, we need to fillet those edges, buddy. This guy. This guy. This guy and this guy need to be 17 mil. We also need to make you a little bit taller. We need to then move you inside there. And we're just going to move you up one. Okay. Now, this minus this is a hole. Yes. All right. Now, same thing. Another cube. I don't know. Something about working with solids just... I don't know. Okay, so we need it to be... So we're going to have to do 2 cubes, cut one out of the other to make the cut for this land. So I need to know outer edge. No. Give me this. Inner edge to inner edge. 156.5. Inner edge. Inner edge. 198.5. Okay. 5. 8.5. Okay. And then that's fine because we're just going to drop it down and cut it out of this guy only. So this is the outer. I then need to know what those fillets are. So this guy. Fillet. 44.25. Okay. Fill it. This guy. Okay, this guy. No. Okay, so first, let's see if that fits in there. Yep, that's in there. Okay. Oops. Oops. Clear those. I now need to know this guy. This guy. That's not what I want. Don't want the angles. So outer, 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 close, new cube. Bring him over here. Okay, and he is 134.7. He is 177.2. Okay. And then the inner fillets on this guy. This guy. No. Outer fillets. So which one is the outer fillets? Second one. 32.85. Right, so this guy, fillet. That. That. Okay. Then cut that from that. Yes. Okay. Now we want this face to this face. Bam. Like that. Okay. We will clear those. And we should see the flange there. Yep. We should see the flange there. Yep. Cool. Now, we need that to be a difference of 2.5 millimeters. Oh. Wait a minute. We'll just do it by meat. Okay. Actually, 6.5. Okay. So 6.5 mil from the edge of the outer flange to, let me turn this guy off, this guy off, that guy off. Okay, so 6.5 mil from this edge to that. Right? Okay. So, we need to move this transform 6.5 minus 2.9. Oops. We need to move it downward. Okay. Now, if we measure this top edge to this surface, it should be 6.5 mil. It's exactly 6.5 mil. Okay. So now, we don't want that. So now I should be able to take that from that. We should have two different surfaces there. So there should be some distance between this surface and this surface. 3.6 millimeters. All right. Which feels about right. Ah, jeez. All right. Now I guess all of this needs to be combined into a single piece. Right? Because that is our cabin air filter box base. I'm then going to want to put... I think what I'm going to do is I'm going to do centering pins, but I'm going to do it... I'm not going to have this surface set against the surface of this guy. Because... So... what I need is then this surface to this surface, Z. Yes. Okay. Okay, that works. What I need to do real quick, this is... cabin air filter box, which we turn off. I then need to cut this hole out. So I need this inner, I need a cube. We'll move them over here somewhere. I then need, since I forgot all the measurements, we can just measure it, measure it, measure it, measure it. Okay. And then cube. Mr. Cube, I need you to be 140.5 and 183. And we'll call them 20 mil. I then need to figure out, I don't remember the fillet on that guy, so So this fillet, 35.75. Oops. Oh yeah. I already forgot the number. 35.75. I think that's the one. We'll find out shortly. Fillet. We'll find out if that's the inner or the outer. Real quick. So this to this line X and Y, please. Also, this guy transform. I believe that's the right one. That looks even all the way around, right? Okay. Cut him out. All right, now that's the body. Body with flange and a hole. All right, now turn this guy back on. And the way this is designed, this outer surface on this outer flange seems to sit flush against that. Okay, now there we go. We want to see, yeah, see there's still a gap there. This line to this kind of plane here, right? This medium gray here. Okay. So now alignment pins. How am I going to do alignment pins? I think just cylinders. We'll make some cylinders, make them concentric, and then just do some sizing funninesses. Right? Is that the best way to do it? Oh, you know what? You know what? Sitting here looking at it. Alright, so this is the body and how it seals, which means we're going to save this real quick. So where we're at is we have the body and airbox. Okay, this is what they look like. What I should do, I guess, is print these out in PLA and verify they match the actual real world counterparts. Right? I think that's what we're going to do. Which means we need to save each of these as their own STLs. Actually, we're not doing STLs anymore. We're doing objects, OBJ. OBJ, OBJ. We don't have OBJ. We can do SCAD. Oh, there it is. OBJ. Because apparently STL, and maybe that's been my whole, a lot of the problems, is STLs seem to have a lot of issues, I guess. And FreeCAD has a lot of issues with fillets. Like, filleting things causes STLs to fail. Like, they just won't print. So let's try SCAD first. I'll try that. This one is the PW body and flange. And this one is PW cabin filter housing. This actually took a lot less time than I thought it was going to make that shape. I keep doing that. I'm like, oh, it's gonna take me like days to make this shape because it's slightly complicated, and then yeah, it ends up not. I don't know if I can fit both of these on the printer bed, but I think what I'm going to do is what I've done before. I'm going to go grab the Canon and the Asus, bring them in here, and just live stream a whole other stream of the 3D printer. So, see, I kind of wish I just had like a bunch of different cameras set up all over the house, and I could just like flick a switch and oh, now that's in the stream. Now that's in the stream. But that's a lot of money. I ain't got that kind of money. I guess you could do it with motion sensors and a Raspberry Pi. But then you'd have to program it. Well, you could, okay, so you could do it with a capture card, and then you run the video out into the capture card. OBS would stream the input from the capture card only, and then whatever room you walked into. But how do you do that with, like, roommates? I guess you just have to have a remote. You do an RF remote, and whatever room you go into, you click a button. You just carry it with you when you're streaming. You click the button, I'm in this room, I'm in this room, I'm in this room, as you move around. It's like none of this stuff that I do is all in the same room. Gaming and FreeCAD and all this stuff. Finally! Well, one. Don't even know who it is. They're not in chat. Just means it's probably my mother. She only says something if it's like important. I needed you to tell me the easiest way to make this shape in CAD. Like just workflow. But I've made it. So the bottom of the airbox there and the flange. So here you go. I can show you. It's right here. So start with body flange, which is just, I just wanted a plane and then the flange that sits on the plane. So that's where your body is. The HVAC box is recessed down in here, like at the bottom of this hole.
You need to dig in the middle.
So I'll show you that here in a second. We're getting there. Turn that on, turn that off. Now this is
Nice.
that. Now the hard part was, because I want the seal to fit all of these gaps.
Right.
I want it to press against every surface.
Right.
Are those the same plane? No. Is this the same plane as this? Is this the same plane as is this the same plane? Is this the same plane as this? So it's all different heights and shit. So I ended up doing
So what you could do, by the way,
one piece at a time out of cubes.
you could have just done it all one big size, taller, than taking a thing and flattening it, like grind it down. Or cut it down. Make it bigger so it fits everything, and then just do it from this end. Then it would be flat. You understand?
I don't want this flat. I need that to be all of these.
No, you make it all taller than it needs to be. And then you make it level with the top of this wherever you need it. So it fits all the crevices because it's tall. And then you cut off what you know do.
Are you talking about the seal? Well, what we're doing is we're injection molding silicone. So first I need to make the shape for the airbox so I know what that needs to be. Then I have to make the shape for the body so I know where that needs to be.
But you could.
Yeah, but then I'll show you the problem with that here right now. The actual problem with doing that is body. So this plane here sits flush against the body when you bolt this thing down all the way around.
I would assume.
Right? So that's what I did is I made that flange and I set the flange, right, this outer flange, flush against the body here. And what ends up happening is the flange in the body sits. So there's your flange there. This flange here is x-rayed, and the flange for the body recesses into this groove some distance, and you have a gap there. So if you mold it here, all you're going to do is you're going to go to tighten it down, you're going to crack this, bend the body, or split your seal if it's just flat. So you have to have this groove that's the body on the flange as part of your mold. Otherwise, you're just cutting everything apart and breaking shit. That's what I was going to do. I was like, oh, why can't I just do it flat and squish it down? But it's silicone that I'm using, so it won't do that. I don't know how to do EPDM. I don't know if you can injection mold EPDM. You have to be able to. It's a foam. I'll look that up too, because EPDM, we could just get rid of this body flange and you just, like you said, fill this all with EPDM and then squish it down on top and you're done. But I'm planning on doing it silicone so you never have to touch it again. Like, ever.
I mean, I'm interested to see what you come up with. I understand your problem with that. But if that doesn't work, we can always, like...
Yeah, so where I'm at right now is I need to print both of these in PLA over the next day or two and make sure that they match what I've done here, because my radius gauge only goes big enough to measure this radius. So the other three, yeah, those. So what I ended up doing, okay, was this material is 1.1 millimeters thick, right? This one I don't care about, but I did the same thing for the flange. It's just 1.1. The body is 1 millimeter thick, okay? So what I did is I did 17 mil here, 1.1 millimeter added to the radius there. I then expanded it, yeah. So what I did, because this is a single radius, it's not an ellipse, it's a circle, right?
You should extend it.
This distance and this distance are different, which means this isn't exactly this distance from this center point or this distance.
Because this is like...
So I did an average. So I averaged those two.
I mean, realistically, so we don't need a zero water type seal. We just need a...
Yes, we do.
Well,
No. The transmission computer sits on the floor. It needs to be perfect.
So here's the thing. Even with the shitty thing it's been, it wasn't always fun.
Well, I think that's because that tube fell out.
But I also think if you make it as close as you can, it'll be good enough. It's only like a couple drops of stuff.
It's rubber. It's gonna squish.
But my point is, don't over stress about it. Okay.
But yeah, but what all I'm gonna do is I'm gonna take and print this out of PLA like half height or something. And that way I can just put it up against here and
That's
match it.
exactly what I would.
Okay.
Boop, boop, boop. And then I would have extended it. It's all good.
Because so FreeCAD, I've told you this before. FreeCAD hates sketching. AutoCAD and SolidWorks, and I think Rhino, are primarily sketch-based things. So I tried, because doing this in a sketch,
Infinitely.
15 minutes.
Yep. Infinitely.
And I was telling the stream that I was like, if I did this in if I had SolidWorks, and I did this in SolidWorks, I'd have been done in 15 minutes making these shapes, and then I pat it, and that's all I would have to do.
Okay.
But doing it in FreeCAD, what it was is build a cube, make it the outer dimension. Build another cube, make it the inner dimension. Subtract. Fill it the inner edge so it adds material. Fill it the outer edge so it subtracts the material. Because if you try to do them all at once, because they're going to be different radii, because there's a thickness there. But if you tried to do it all at once, if it was some method of doing that in FreeCAD, it would, because FreeCAD hates fillets. It hates fillets. FreeCAD wants to take fillets out with an A10. Just that, what is that, a 30 mil cannon. And it just wants to go. That's what it wants. It hates fillets. So, I have to do this shit one step at a time. Okay, so. Yeah, so we've got those saved. I need to go. Do I want to do it today? Do you guys want to see? I mean, it's going to take half the night probably to print these things. So it probably would be good to get started on it right now. So, okay, we'll put the be back in a moment message back up. We'll do that. I will then go grab the Asus and the Canon. You know, I could just I need a second. Every time I think about things, I'm like, I could do this if I had another extension cord. Tell you what, though. No, because I like having Repetier hooked up, so I'm gonna leave. No, I don't have to. Yeah, you leave the Canon and the hub. It's fine. It's fine. It's fine. We're gonna go grab the Canon and the Asus. I'm gonna set them up in front of the 3D printer. I'm gonna start a second stream. You're not gonna have the audio because I won't have the mic in there. But I'll talk about the things when I get back in here. So I'm gonna take this stuff back out to the Graggy Aggie. Cables are crazy tangled up right now. I did say I needed to unravel them the other day. But it's fine. It's fine, we're fine, everything's fine, it's all fine, it's all fine. Everything's fine. Okay. Got this here in my hand. It's in my hand. I need to plug it in to power. Plug outside. Well, power plugged. USB plugged. OBS. Start a new stream. Thumbnails, thank you. Okay. start that guy. So there is a new stream running that is just a 3D printer. It is going to be that guy, which is currently not doing anything. Actually, what it's going to be is not that guy. This guy. Like that. That's what it's gonna be. Okay. And what I gotta do right now is start up Repetier. And Prussia. Oh, oh. Whee! I get off the thing! Oh no! Okay. Repetier. Can you home and then start up the heaters for me, please? And then Prussia. Put both of these guys in here. I guess the question is, can Prussia open SCAD? I don't guess it can. I guess I need to export them as STLs. Try OBJ. See if OBJ is better. We shall find out. Okay. Export. This one is cabin air filter body. That. Except make it an OBJ. This guy. Export. And then... Oh, it doesn't pop up the window for you guys. Nice. Go back to SCAD for a moment. Body flange. OBJ. Save. Now let's see if we can open the thing over here. That. And that. Copy. Paste. Okay. Can you open that? You can open. Okay. Flip onto this side. And that is big. Okay. We are going to be PLA fast. PLA. Print settings, just to verify. Infill, I actually want, well, not for this guy. 10%'s fine. Grid is fine. Skirt and brim, no brim. No supports. Well, there's not any supports that are going to be. Oh, that's fast, fast, fast. $200. Okay. Filament settings. 20565. Sounds like I'm talking about tires. Okay. Okay. So, slice now. That was fast. 4-ish hours. Okay. Yeah. Boom. Actually, I need to move the I need to move the extruder up so that I can swap the filament out. I can do it on the floor, but it's easier. G0, Z150. Okay, do that move for me. Bed, please. There we go. Okay, be right back. Alright, now we export. This guy from Prussia to SD card. We then open the other guy. No, no. How about? Okay. And if we slice that, Let me export that. Come into Repeteer. I want to see real quick. This guy, what he looks like in the this way. This way. How do you? There we go. Shift. So, yeah, we just want to cut the bottom end of it off. Just so we can see. Look at that aliasing. Okay, so, where's our layer? Yeah, that should be okay. Okay, what are we doing in here? I don't know why I'm moving around in there. This is what we want. This is what we want to see. Alright. So, yeah, we want to eject the card. Bam. Cool, cool, cool. Now let's go put the card in and start one of these bad boys. I would just sit around and wait for 4 hours. What do you guys want to talk about? What do you want to talk about for 4 hours? I did not check the bed level or nozzle height before I did this. So we'll find out, right? Yeah. Alright. I don't know. What am I doing now? Did I save this? Save it. Okay. Get rid of that. And go to this. Because I don't know what else I could maybe possibly perhaps do today. Other than watching the print. I've been playing Ixion, but I can't get the freaking thing to work in a stream. For whatever reason, it just keeps crashing. Which is odd. I kinda want to go find something to eat. Sit back, watch a show for a bit. And I might come back in a bit. Might come back in a bit. Get into Satisfactory Update 8. I need to record and make videos instead of just, you know, streaming. guess I can go check out, yeah, I don't know that there's anything else that I'm doing right now that is going to be useful in a stream, so we'll probably just end it here. And I need to get a hold of the owner of the van and talk to her about what she wants to do, because I'm not just going to go buy parts willy-nilly and charge her for them. But it needs a radiator at the very least. They're $200. Remember when radiators were $89? Every radiator was the same, like just $90. But that is out of control inflation for you. That's what happens when you shut down a planet for 2 years. So, yeah. I think we're done for the day. It's been a thing. Semi-nightmare, because FreeCAD is just ridiculous. You know. It is what it is. Anyway, we'll see you guys later. Hope you have a good night, or a good day, or a good drink, or a good party, or a good petting of a pupper somewhere. And we'll see you tomorrow.